Yo chat, what's up? Oh wait, where's my chat even? At some point I had a window with chat in it. We'll find it. It has to be on one of my desktops. It's a good first exercise for today. Oh, found chat. Yo, sicher nicht. Yo, Ape here. Can't stay, going to be in classes for the next few hours, but I hope you're doing all well. Yeah, sure, no worries. Enjoy classes. It's a bit early for me as well, so no worries at all. No worries. I mean, no worries in general, right? Happy for people that are here, and I don't mind if people don't have time. Hope you're also doing well otherwise. Yo, my water is boiling. Be right back. Oh, I forgot to turn on my light as well. Silly streamer. Doing pretty well, thanks. That's good to hear. Happy to hear. Oh. I don't really have a plan for today. I don't really have a plan for today. I will be doing some... Oh. There's actually something I have to do, but I can't do that on stream. Well, later. Or another time. Let's put that here. I will be doing some... whatever the title says. Manim dev stuff. And in case there are any questions, I'm happy to answer them. My plan is to finally write like some more paragraphs for the new deep dive tutorial, because otherwise it will never get finished. And I see that there's a very real outcome actually, that it will just never be finished. Because someone, me, doesn't have time for finishing it. So that's why we should sit down and do it together, chat. You're in this now. So, I mean, I've managed tea, I've put on the light, maybe I'm almost ready for showing something. I guess it's time to open VS Code. That's the next good exercise, I guess. All right. Let me resize some things here a little bit. That's better. And then second step, move this here, and then we share desktop. All right. Let's try to write a little bit of the tutorial thingy, and then in case we get bored, we'll do something else. Maybe we'll look at one of the recently added issues or something like that and take care of that. Or if there are, as I've mentioned, if there are any questions, I'm also happy to discuss those. That can go here. Let's put that here. This here. All right. Okay. That's probably still too small for anyone to read. Let's increase the font size like once or twice more. We're mostly doing text, I think. So it's better if it's legible. That should be fine, I guess. If you want me to increase it further, chat, let me know. I can do that. Let me briefly, though. Switch to the other mode once more. Other screen. Wait, is my keybind working today? It is. Wow. Today's a keybind day. Sometimes they are actually working. Let's move this over. I'll open GitHub in the browser and we can go back. All right, Manim, there we go. Perfect. So, there are actually some new pull requests that we also could look at and make them move along. We can do that later, I guess. Let's try to work a little bit on the tutorial first. Oh my god, it's so far down already. Where is it? New tutorial, this one. 2550. Why is my bar not staying on the screen today? It's annoying. GitHub check out. Wait, is there anything that I've changed in the library? No, all of that is in example scenes. It's fine. GitHub check out 2550. Nope. Wait, what? Wait, what? I haven't used it in so long that I forgot how to use it. That's not great. There we go. Deep dive. What is he unhappy with here? Weird. I mean, that's fine. Okay, let's render this and then take a look at where we are and what we need to do to get some sort of overview over the situation. And maybe let me do one more thing. Why is my bar not staying where it... Oh, I hate it. Manim dev stuff. Okay, there we go. All right. Sorry, chat. I'm kind of distracted right now. It will be better in like a minute or two once I'm actually done with all the things. I should probably do these things before I go live. But well, it is how it is, how it is. All right. Let's render the current state of this. Docs. Make HTML. O equals minus T skip Manim. That's so the. This is so the examples in the documentation don't get rendered because I'm not interested in that right now. I just want to see how the page looks. Then we open it and then we look at it and then we decide whether this is worth continuing today. Lovely, some errors. Also, let's change the music to something more. Okay. Much better. Wait, there's still so many of these? I should probably merge the latest main branch. Let's do that. That beat though. Was this smart? Maybe. Git fetch origin main. There's gin in origin. Git merge origin main. Well, now it's better. Clap. Do it. All right. And now let's render again. Because stuff might have changed. Now that we are on the latest master. Main. When did I pour my tea? Was it already like 10 minutes ago? Probably not, right? Not that long ago. Let's wait for a minute or two more. I'm craving tea. I mean, it's too hot to drink right now anyways, but about 7 minutes. Did you check? About 7 minutes wouldn't be too bad actually. Work faster, things. Do your thing. we want to look at the documentation local. Unknown document, that's not great. Oh, too late. Open. Build HTML tutorials. Deep dive. Why does it always use like random stuff? Give me a moment to fix this without leaking any information. There we go. All right, there we go. Okay, here we are again. Here we go again. So we started with the introduction. I wrote this thing. We have our toy example, which has some things in it. Orange square, blue circle. We do some things with them. Hey, Toykische. Good evening to you too. Overview, we need to write that. Preliminaries, we need to write that. No, that's actually already written. I think preliminaries is actually the one chapter I've more or less written completely. Back in our toy example, here I see stuff not rendered correctly. Manim stream. Yep. I'll do some Manim for a little while. And then if we get bored, we change to either more Manim or I stop streaming or I don't know. We will see. We will see indeed. Ooh, there's some... I kinda wanna... Should we check, before we do actual work, should we check what people... Should we check the recent notifications on our Manim community Twitter thing? Maybe people did some fun videos or so. I'm just looking at it, and there's at least one. That seems pretty cool. Let's check it. Let's check it and do some stuff. Wait, let me see. I need to be sure that I don't leak anything. This is here. All right, there we go. Notifications. All right, there we go. There we go. So, what are the recent? I've posted this. There's some stuff here. There's some stuff here. Okay, this we already retweeted, so that I've seen already. What's that? Oh, there's a fate transformation. Fun. What's happening here? Ooh. Parentheses. I like parentheses. Yo. That looks like some sort of formal grammar thing. Should I read the text as well? Maybe. This is supposed to be derived in artificial chemistry from a Turing-complete calculus named combinatorial logic. The basic elements... I can actually make this larger as well. The basic elements in this chemistry are the combinatorics S, K, and I. To see how it works, first imagine a vessel in which they introduced in equal numbers. Elements in the vessel are randomly condensed into larger compounds by means of a multiplication operator X, Y, and conversely can be stochastically cleaved into X and Y. Oh yeah, that's fun. It's like it. Crucially, blah, blah, blah. One kind is associated with the I combinator for any compound of the form alpha IX beta. There's a reaction where I detaches itself. Ooh, detachment. That looks fun. Let's like this as well. Nice video. What happens here? K combinator applied 2 arguments will result in only the first argument. While both the K combinator and the second argument Y are released as byproducts. Ooh, that's fun. We'll also like this. Separate copy. Fun. Complete system features a mix of slow-paced random recombinations and reactions and fast-paced Turing-complete reactions. Picking up the examples, simulations from before, and now let's continue it, but reduce reactions. Oh, so lots of stuff is happening here. I would skip for this song. Wait, does my skip button not work? Let me check. Huh. Weird. Where's my OBS? There's OBS. Hi chat. I thought I had lost you for a moment. Sorry. More parentheses. I mean, I like these sort of grammar things. Let's like the videos. There was somewhere... Yes, this one. Animations of what we're done with Manim community. Let's retweet that actually. Fun. Alright. Watched it, looked at this thing. What else do we have? I saw this. This is probably fun. Should we check out the full thing? Let me quickly check how long the video is. I really need to have a better key binding for switching scenes. Oh, it's like 2 minutes long. We can watch that. Let's watch chat. We need to see what people are doing with Manim. Oh no, I forgot that when I play a video that my thing button is certainly broken again. Yo, but this does have music.
We may also encounter functions that are not bounded, for example,
you don't see anything. My god, I'm bad at this today.
But is it possible for a function to be unbounded in a neighborhood of every...
Okay, let's do this.
In analysis, we usually deal
Close.
with continuous functions, and they are bounded on compact sets. We may also encounter functions that are not bounded, for example, when they have a vertical asymptote.
Yep.
But is it possible for a function to be unbounded in a neighborhood of every point of its domain? Consider the following function. Every rational number can be represented as a quotient of 2 integers. But for this function to be well defined, we require that the fraction be in lowest terms, and that the denominator be positive. The sign of the fraction is therefore encoded in the numerator. To get our feet wet, let's visualize this function. The yellow part corresponds to the irrational inputs. It looks like a solid line because the irrational numbers are dense in the set of real numbers. The blue part corresponds to the rational inputs.
Ooh, that's pretty.
Amazing pattern, isn't it? Do you see now that this function is not bounded in any neighborhood? Look at the values corresponding to the prime numbers. They are getting dense as we move up the y-axis. Let's prove that this function is everywhere locally unbounded. Assume, on the contrary, that it is bounded on some
yes, I mean you have
C,
fractions
D.
everywhere.
This means the denominators of the rational numbers from this interval are bounded. But this, in turn, implies that the numerators are also bounded. It follows that there are only finitely many rational numbers in the interval C, D. This is impossible because the rational numbers are dense in the set of real numbers. This contradiction proves that the function cannot be bounded on any interval, which is exactly what we wanted to prove. We have constructed an example of a function that is everywhere locally unbounded. But can you construct an example of a function continuous at a single point only? Make sure to watch the video shown on the left for an answer to this question.
Good stuff. I liked it.
What's it like to learn math on Brilliant?
No, thank you. We definitely like and retweet that, right? Good stuff. Yeah, and then that's what I did just now. That's what I did just now. All right. We could retweet it as well, actually. I mean, if people have questions, why not? Sure. Why wouldn't we? All right, back to work. I'm ready, chat. Maybe. Let's move this back here. So, where were we? We just saw before we started watching videos that this here is a formatting problem. We have to fix that. Shouldn't be too hard. It's just that you can't do something like this. So we have to reformulate this part a little bit, and then we talk about objects and Veeam objects and all these things. Right, let's go. Where was the typo thingy? It was here, right? Back in our toy example, the call to scene render first triggers the scene setup, which simply passes. How would you say that a method is implemented just by passing? Should we say that there is no operation? Should we just say something with pass? Which only consists of pass. Let's write it like that, that's fine. Followed by a call of construct. At this point, our animation script is run, starting with the initialization of orange square. Right, we should open our toy script. So the orange square is the first thing that is being initialized, and now the next thing that we should do is we should talk about the difference between mobjects and vmobjects. And the first thing that I thought of when I wrote the structure here was we should discuss what a mobject is, and then we should discuss what vmobjects are. All right. I mean, I guess we can do that. Let me head back here just to make sure that I see stuff. All right. Brief discussion of mobject and its init function. So what do we need to say? What do we need to say? Mathematical object, base object for objects that can be displayed on screen. And otherwise it doesn't really say anything. There's not even any documentation about there's not even any documentation about the methods that it has, or the input parameters. Nothing. It's not great. So what sort of important attributes does an object have? And what happens during its initialization? I mean, we've went through all of this in detail a few streams ago, so I don't want to discuss it in detail right now. I actually just want to write it up. I should have maybe done a bit closer to when we discussed it, but well, we're here now. We are here now. That's fine. I mean, basically, there's not much happening in this thing. Base attributes of the object are set, like its name. The list of subobjects is set to the empty list. Updaters is set to the empty list. Updating suspended is set to false. The color is set to whatever color is passed. And then the point stuff is called, and then edit colors is called. Should we look at colors again? I feel like looking at colors might actually be worth it. The question is just whether we want to do that. So what does reset points do? That just does nothing, does it? np.zeros and there's a tuple 03. Because self.dim is always free, isn't it? That's actually something I'm interested in right now. Is the dimension parameter ever modified anywhere? Self.dim equals free equals free equals dim. Why do we even need that? "39 matches. I have to retract my flame against GitHub Copilot. Some really sick suggestions today. Sweet. I wait for the day when GitHub Copilot can just clean up the library. That would be great. Just rewrite everything. Just give it the doc strings. Which doc strings though? I mean, honestly, why does the OpenGL line have to set its dimension to 3? Why do we even have an OpenGL line still? Shouldn't OpenGL geometry be gone? It's kind of weird. Self.dim. To be quite honest, I think that all of these can simply be replaced by 3. Which doc string is copium? Yeah, GitHub Copilot can probably write a more stable library than whatever this is. Should we open an issue for that? I kind of feel like we should open an issue for removing the dim parameter. Attribute. Well, anyhow. Based on this, what do we say that the object is? It's a base class, right? The important thing is we are writing stuff for the Cairo camera. The camera knows some things. Mob. Okay, here we go. I'll write like a sentence or so, and then I'll be back at stalling. Class mobject is the stands for mathematical object or Manim object, parenthesis depends on who you ask, smiley. Can I just it's true actually. People are not there are multiple opinions on what means. And we would need to ask. We could ask Grant actually. Maybe he has time to clarify. Objects. A class mobject. The Python class mobject is the base class for all objects that should be displayed on screen. Looking at the initialization method of object, you will find C blah blah. Actually, let's fill blah blah with something. Manim mobject. This is not a main, yes. And here I want a link to this. Copy permalink. I'll just paste it in. Let's put a link. Here. Brackets, link, double underscore. You know what? Actually, we could turn the initialization method to a link. That's actually cleaner, I think. Initialization method. Brackets. Copy. Remove. Paste. Looking at the initialization method. Of an object. Actually, can I break this? I think I can. This is one thing that things should allow me to do, actually. At the initialization method of an object, you will find that not too much happens in there. Colon. Itemization. What happens in there, actually? Some initial attribute values are assigned, like name, which makes the render progress bar and log files mention your object and logs, which makes the render logs. Mention the name of the object instead of its type. Skip. ISNP np.zeros, a tuple containing a 0 and then a 3. That's an empty array of shape 0, 3. That's good for you. Congratulations. Would be interesting what GitHub Copilot would suggest as documentation. Maybe, yes. Maybe. I wonder whether GitHub Copilot would write this better and more accurately than I could. Does not process pure class object. Let's do it like this. Objects in any way. They cannot even appear on scene in the rendered output. This is where different types of objects come into play. Roughly speaking, the Cairo render setup knows 3 different types of objects that can be rendered. Vim object class Vim object let's do it like this so that we can actually Vim objects which are vectorized let's copy this like how do we do this? I want to explain Vim objects in this next paragraph here, and I don't want to explain too much here. I'll just explain this last thing. Class P object class image object P object Vim object which represent images that you can display in your scene. P object. Is there a one-sentence documentation of what a P object is? Otherwise, I will say something arcane here. P object. Objects representing point clouds. A disk made of a cloud of dots. Which are special, very special objects used to represent point clouds. We will not discuss them further in this tutorial or in any other tutorial. And finally, Vim objects. Which pretty much are vectorized objects. That is, objects that consist of points that are connected with curves. These are pretty much everywhere, and we will discuss them in detail in the next section. Great! Alright, wrote one section on something. Let's build it and look at it. Look at all of my linking mistakes. Yo, hey, Marcus on Twitch. Thanks for following. Appreciate it. Where is it? There it is. Great link that you have there. Okay, otherwise, this looks kind of okay, actually. The links are actually mostly okay, even. Except for this one. So I messed this up for some reason. Where was that? Here. Looking at the... is it maybe just the double underscore that I was missing? I don't see it anymore. It's gone. It's here. And it links to the correct thing? Easy. Second try. Easy. All right. So let's read. Backing out our example is call to scene.render, first trigger scene setup, which only consists of pass, followed by a call of scene construct. At this point, our animation script is run, starting with the initialization of orange square. Objects are in a nutshell the Python objects that represent all the things we want to display in our scene. Before we follow our debugger into the depths of object initialization code, it makes sense to discuss Manim's different types of objects and their basic data structure. Object stands for mathematical object or Manim object. Manim object, depends on who you ask. The Python class Mobject is the base class for all objects that should be displayed on screen. Looking at the initialization method of Mobject, you will find that not too much happens in there. Some initial attribute values are assigned. Did I even spell check this before I did anything? I probably didn't. Like name, which makes the render logs. Mention the name of the object instead of its type. Yeah, if I do something really boring like this, apologies chat, this is boring. If I do something boring like this, at least I have to put on some music that makes me not fall asleep. Some objects like initially an empty list, color, and some others. Then two methods related to points are called. Reset points followed by generate points, and finally init colors is called. Digging deeper, you will find that mobject reset point simply sets the points attribute of the mobject to an empty number vector, while the other two methods, mobject generate points and mobject.init colors, are just implement this pass. This makes sense. Mobject is not supposed to be used as an actual object that is displayed on screen. In fact, the camera, which we'll discuss later in more detail, is the class that is, for the Caillou renderer, responsible for taking a picture of the current scene, does not process pure objects in any way. They cannot even appear in the rendered output. This is where different types of objects come into play. Roughly speaking, the Caillou renderer setup knows 3 different types of objects that can be rendered. Image object, which represents images that you can see, that you can display in your scene. P object, which are very special objects used to represent point clouds. We will not discuss them further in this tutorial. And V objects, which are vectorized objects, that is, objects that consist of points that are connected via curves. These are pretty much everywhere, and we'll discuss them in detail in the next section. Yo, that's kinda okay, I guess. I've written verse. I've written definitely verse. Sounds good. Yeah, I think so. I think we can leave this for now. Okay. More T. And then we will continue with Veeam objects. Okay, I'm ready. We have to seize this wave of motivation that I have right now in this moment. What are Veeam objects? Let's repeat what we just said, just because that's perfect style if you do that. As just mentioned, class Veeam object Veeam objects. I think we should push for switching REST syntax for Markdown, because I would be so much faster if I would write it in Markdown as well. REST just gives me such a headache with links all the time. Well, anyhow, as just mentioned, Veeam objects, chorus. It's just really strange. It really is. Represent vectorized objects. Or let's just say vectorized. Vectorized objects, vectorized objects. They consist of their points array is their points attribute is very special in the sense that before I do anything now, we should actually look at an example to breathe this in a little bit. Maybe I'll actually include this in the text as well. So let's go and open up a new file. Veeam object stuff. Pi. In where? That's the wrong directory. Manim. Example scenes. There we go. From Manim import star. Class test scene or vmobject test scene def construct self. Okay, and now let's play with the points attribute of vmobject for a little while, just to make sure that we understand how it works before we actually write something about it. Okay, so here's what I'll do. Vmob equals vmobject, an empty one. I don't do anything with it, and then I'll set the points attribute directly. So I'll set vmob.points equals. We will need to write this as a numpy array. So we will need to write np array. Let's put like 4 points because we need to put at least 4. 1, 2, 3, 4. In my understanding. Let's see what happens if we put 3 points. I hope that Manim shouts at me. 0, 0, 0. Then let's put the next one to 1, 1, 0. And the last one, let's put to -2, -1, 0. Okay, let's go. Self.add vmob. And then let's render this. Let's see what happens. Example scenes, Manim qmp vmobject stuff, vmobject test, go. Nothing. Interesting. I would have expected something. Let's set the color. Okay, does it change if we add more points? 4, 3, 0. Aha, there we go. Okay, so what do we see? We see a Bézier curve. These points are always processed in tuples of 4. Actually, let's add the number line and let's maybe make this a nice example. NP is bad. Plane equals number plane self.add plane and then object, and then we can look at it again. So what can you see here, chat? We have 1 point in the origin, which is the first point in our points list, and we have 1 point at 4, 3. This is the last point in our list. So the first point and the last point correspond to the... Now I have to be careful because the terminology is confuses me sometimes. 2 of them are referred to as anchors and the other 2 are referred to as handles. Now let's think of what would be what. Probably the first 2 are the anchors and then the second 2 are the handles. If I wanted to make like a little rotated S-shaped curve, I would put my... Let's do it actually. Let's just do it. I talk. I would put my anchors at the points where we start and where we end. So that's at 0, 0. And at like, let's make it 2, 2. And then I'll put the handles. Above and below those respectively. So that would be 0, 1 and 2, 1. And that should be now a nice S-shaped curve. Yeah, exactly. So the anchor points is this one here and this one here. Remind me that I actually check whether I use anchors and handles correctly. Here, and then the blue point we've set to here as well. That's how the curve is generated, right? More or less. Let me some things, but more or less it looks like this. Actually, a little bit more, a bit closer even. And these 2 points are referred to as anchors, I think. Not here, at least. We'll see. The way how this is interpolated is the following. You draw basically. That's not for the quadratic curve where you have just one of these control points in the middle. Less voice, please. So what you do is you divide the segments between your anchors and handles into, well, whatever ratio there is. So this is like if 18% here, you're 18% here, and so on and so forth. And then you connect these two. So you're here. And then on this segment here that connects these points with ratios on the two lines, you again do the same, you again take the ratio. So again, on this line here connecting the 18% point on this line segment here and the 18% point on this line segment here, you take again the 18% point on this line segment. And what happens then is you get a point on the curve. And this construction here is known is known as de Castrios. That's exactly a Bézier curve with the given. I should actually check what Manim calls anchors and what does what does Grant call anchors and what does he call handles. Vectorized object. Anchors. The anchors are the endpoints of the curve and the handles are the control points in the middle. Exactly. So Manim uses or the Cairo renderer uses cubic Bézier curves, and yeah, which means that there's always these collection of 4 points that make up one curve, and whenever you for any object we have in mind. Sure, why not? Good library. I mean... if you say so. No, it's pretty cool. The question is, what do we say here, though? Because I don't want to reinvent the wheel with BCA point. primer on Bézier curves. What do we need to make? HTML O equals minus T skip Manim. My fear with this tutorial is that we probably have to split it up at some point because it's way too long. Nobody will read that. But it's not the worst thing, actually. because it's at the moment the structure is very clean and we could easily distribute stuff around. I just need to write this like in one sitting, so it makes sense to keep this in one document for now. Okay. How do we look? Ah, Pomax, I have not. Wait, did I just close it again? There's Pomax. Should we? He certainly has information somewhere. Let's use his Twitter. Copy link. There we go. Okay, as just mentioned, Vim objects represent vectorized objects. To render a Vim object, the camera looks at the points attribute of a Vim object and divides it into sets of 4 points each. Each of these sets is then used to construct a cubic Bezier curve, with the first and last entry describing the endpoints of the curve, anchors, and the second and third entry describing the control points in between, handles. To learn more about Bezier curves, take a look at the excellent online textbook, blah blah blah. There's an online playground in paragraph 1. The red and yellow points are anchors and the green and blue points are handles. I think that's good, isn't it? And I think there's actually not that much more that I want to say here. Maybe we add a little Manim example that people can use to render and look at stuff. I feel like that might be worth it. Question is how crazy should the curve be? Not too bad, probably. To illustrate, in contrast to class mobject, class vmobject can be displayed on screen, even though technically. Oh, stop. Technically, it is still considered a base class. To illustrate the usage of points, to illustrate how points are processed, consider the following short example of a Vim object with 8 points with 8 points And thus 8 divided by 4 equals 2, made out of 2 cubic Bezier curves. How do we do that? We'd probably just write it like this. Manim. So how does this work? I haven't written an example in like forever. Vim object demo. Save last frame. And then we just put the code here, I think we do. From Manim import vmob star. Do we do that? No, probably not. I've not seen that in forever in examples. From class vmobject demo scene def construct self custom vmobject my vmobject equals vmobject color equals green because I like that. My vmobject dot points equals. All right, there's the list. Wait, is this enough? Yeah, okay, that's fine. 1, 2, 3, 4. And p dot array something comma. So 1, 2, 3, 4. 1, 2, 3, 4. Should we really do that? We just go for one curve, but I do wanna see how this is handled. I think it pays off to have like a 2 curve Vim object. First anchor. Start anchor. Start point of first curve. Then the 2 control points, and then there is the end point of first curve. Start point of. Maybe we don't need to write point. Start of first curve, end of first curve. Start of second curve, end of second curve. Let me also, before we write this example, let me also add a warning. But I mean that can go after the example, I guess. Warning. Manually setting the points of your class vmobject is usually discouraged. There are specialized methods that can take care of that for you, but it might be relevant when constructing or when implementing your own custom object. Vector Vim object. All right. All right. Now let's get some points. And a plane. number plane. Self.add plane my object. Okay. Is there a thing? Wait. What happened? Oh. All right. Sorry, I got distracted, chat. I got distracted. All right. Why am I actually not here? That's so weird. Should reload this. Okay, there we go. Wait, maybe there is something that I should take care of. No, it's fine. Oh wait, there's a new YouTube comment. Oh, we should maybe check that out. That's something that might be a question for the stream. But I'll do that later. Hopefully a nice one. Yeah, to be honest, I feel like pretty much all of the YouTube comments I get are so nice and heartwarming. I'm just some random person that explains how Manim works, and people watch hours and hours upon this. It's really, I don't know, it's a very nice feeling. Okay. Yo chat, what are your random points in the 2D plane? What are your favorite points in the 2D plane? It's great. It is. I'd say we put some 6-9. That's outside of Manim's frame, unfortunately. And I'm not gonna scale the whole thing, just that this works. I could do 0.6 and 0.9, but I'd rather take integer points. Yeah, I knew that would be the next suggestion. Okay. Then I'll start with one. Let's put all control points to 0, 0 for now. 0, 0, 0. 0, 0, 0. And then we, I don't know, reevaluate life choices after we look at this first. Let's start at like -2, -1, and move to 1, 3. So it's like loop, and then we move from 1, 3 2. I feel like I have to put 4 minus 2 or something like that so that we get 42. 4 minus 2, 0. Okay. Let's take this over to our other thing where we can try around. If we visualize the control point somehow, but I feel like that's out of reach for this here, because I don't wanna blow up the code of the example too much. So it is what it is. I wonder whether it's worth to do something. Yeah, whether we should add some points, some lines. But then I feel like that example would blow up. But maybe it's not so bad. If I had like thin lines from the... Can Manim do dotted lines? Yeah, it could. It can certainly do dashed lines. That's enough. But I think like thin red lines would also work probably. The question is just, can we do that somehow easily in code without repeating the points yet again? Actually, that's not even that hard. I can just do something. I could just do something like this. I put handle lines, and the lines should go from P1 to P2. Color red, stroke width small. Just one line. Or P1, P2 in or can I do that? Can I do it without a double? Wait. I don't want to index over them. It's that I don't want to use eta tools, and I don't want to index over anything. Oh, this is difficult right now. No eta tools, please. I'm sure it would be easy with eta tools actually, but I don't want to use eta tools. That's usually more confusing than it helps. I need to group them in tuples of 2 each, and I feel like there's not much I can do about it. The alternative would be indexing. That would work. But then I have something ugly here. I would have my vmobject.points of index and my vmobject.points of index plus 1. So much code. Yeah, that's my problem exactly. From this to this, color red, stroke width 1. Oh my god, 4. But then at least we can write this short. 4 index in range len my vmobject from 0 to that in steps of 2. Yo, yo, yo. What up, chat? Is this not done yet? Reading sources. Oh, no, it's done. It's really slow. I was worried it was stuck. I also put some new water on in my boiler kettle thingy. More tea coming up soon. There are almost no errors. Great. More tea. Yo, the first batch of tea today was Svartvinsbeer, which is blackberry. I'm ready. I'm ready. Now I'm actually ready. Okay. So, what's the status of things? This looks like an example. This looks not so bad even. I'm tempted to say I'm happy with this. I mean, it's just, the amount of code is not great, but I'll take it, I guess. The handle visualization is good though. I think that's worth it. It's not that bad, right? But maybe we explain this a little more. Consider the following short examples of a Vim object with 8 points. And then let's add some text to explain this picture here. That's a good idea. Right, and then there's this warning with regard to setting the points attribute to yourself, which you should not usually do, but well, you did it because we are just extreme in every regard. Consider the following short example of a Vim object with 8 points. The resulting Vim object is drawn, that is the concatenation of the two cubic Bézier curves is drawn in green. The control points are the handles belonging the handles including the are drawn as red dots with lines representing the closest anchor. Representing as red dots with a line to their closest anchor. Let's actually stop putting handles and anchors in quotes. All right, and then that's a good explanation, I think. Let's read it again. To illustrate how points are processed, consider the following short example of an object with 8 points, and thus made out of 2 cubic Bézier curves. The resulting object is the concatenation. I don't think we need that. Previous sentence already says that. Is drawn in green. The handles are drawn as red dots with a line to the closest anchor. And then the image. That's not too bad, right? Red dots, lines to the closest anchors. So these are the handles. You can see how things are connected. Okay. And then I think I'm ready to go back to the actual example, because this was basically a short digression into how vectorized objects in Manim work, at least to some degree. We have not touched or talked about color at all, and I will try to not touch color too much, because the way how color exactly is handled is probably the one thing I'm not entirely sure about. Not sure how the gradients are really set and stuff, so and in particular the data structure behind vectorized objects. Method. Yo, hey, Snoo Studios. Nice to see you again. How are you doing? How long is my tea? No, it's not set yet, I think. Let's wait for like 5 more minutes or so. Good, quite busy. Ah, sometimes that's nice being busy, and sometimes it sucks. What does square? That's in geometry. No, it's no longer in geometry. Wait, it's in where is it? Line? No, it's. Do we have a shape thing? Wait, how is it called? Polygram. Probably in polygram. Square. Class. Right. So as I don't want to duplicate any code, especially not code from the library because that doesn't deserve to be duplicated, I will simply go and reference this. Can I not get a permalink from here somewhere? That was possible at some point. No, don't see it here. Well, we'll do it. Let's do it like this. Maybe let's do second one before we do and so forth. UL is up left and equal to up plus left and so forth. Assume The debugger. The initialization function of polygon is particularly simple. It only calls the constructor. It directly differs, or directly calls, only calls the initialization function of its parent class polygram. And there we have almost reached the end of the chain. Polygram inherits from Veeam object, whose constructor only sets some default initialization function. Let's stick with that. Initialization function mainly sets some default attribute, sets the values of some attributes, quite similar to the initialization to mobject.init, but more specific to the Bezier curves that make up the object. There also is after calling the initialization function of class VMObject, the constructor of polygram also does something somewhat odd. It sets the points, which you might remember above should actually be set in a corresponding generate points. up, which take care of setting the quadruples of anchors and handles appropriately. Okay, and with that, I think everything is I'm just documenting something. Someone is breaking into streamer's house while he is streaming. Yep. After this, continued up until including up to initialization of orange square. How large was that commit? Yeah, I mean, 168 lines, that's not too bad. That's not too bad at all. All right, with this, I think I'll call it a day. Because, well, one line short. One line short of 169 insertions. Yeah, I'm sorry. Not nice. Almost nice. There's also no 69 in the time or anywhere. I mean in the time it's hard to get 69. Maybe in the commit hash somewhere? Oh, also 68 here. Unlucky. I mean there's 96 that counts basically, right? 96 counts basically. I can claim I'm dyslexic. It's probably enough. I let it count. Okay, thank you. Yo, but that's actually quite substantial. So let me push this. Does it know where to push? I hope it does. Yeah, it does. And let me link the PR in chat for people to take a look if they want to. So thanks everyone for hanging out. This has been, well, basically we're still working on this new tutorial that explains how the library works in a more in-depth way. We have a YouTube video corresponding one actually. Let me also link it in chat. My key binding, my OBS key bindings broke again. Interesting. So that can happen during the stream. Very interesting. Let me link. So basically, so that people can have an idea of what we're actually doing. There is this thing. This video, which was a previous stream where we stepped through the render loop of Manim with a debugger, and now what we're trying to do is write that stuff up somehow so that it becomes digestible. Because I mean, if you're really interested in how the library works, you maybe want to read something and not watch a 3 hours video of me drinking wine and discussing the debugger. I mean, that's also, if that's up, if that's to your liking, sure, why not? But I feel like most people probably rather read the tutorial, a written one. In any case, feedback to my changes is appreciated, and if you want to learn something from, I think the tutorial actually is in a pretty good state already. So if you're interested in how objects work and how what Manim actually does when you run Manim -qm something, then go and check out the pull request. I'll link it again. And actually also this here, this is the rendered version of it. Copy link. This one. If you feel like reading through this to get an understanding of how the library works, then feel free to do so. Leave a comment. And yeah, eventually this will be done, but it might take some more time. Very cool. Thank you. Yeah. Thanks for hanging out, even though this was a more boring stream than usual, I'd say. I'm aware that me writing text is not the most entertaining thing that I could stream, but it needs to happen at some point, and if there's someone around that I can talk to while I'm writing text, it feels even more fun. Right. So yeah, thanks for hanging out, chat. See you again soon. Maybe we continue this again in another Manim stream soon, but there's also more gaming that I'd actually like to do. So games soon again. Mahlzeit. Dankeschön. Have a nice evening, everyone, chat. See you soon. There's no translation for Mahlzeit. There simply isn't. There simply isn't.